In this X-Minute Math video, we're going to be looking at how to factor a quadratic polynomial. And we're going to stick to the simple case where the x squared term is just that. X squared, no coefficient of 1. Now, factor a quadratic just means write it as a product of two linear factors. So let's dive right in with an example. So the quadratic expression x squared plus 7x plus 12 can be written as the product of x plus 3 and x plus 4. Now the great thing is we can check this by just applying the FOIL method to expand out our brackets. So let's pair up our terms. First, outside, inside, last. And when I do these products, I'll get x squared plus 4x plus 3x plus 3 times 4, that's 12. So that's really nice. We know this is the correct factorization of that quadratic polynomial. So we've managed to reduce our quadratic to the simpler form of two linear terms multiplying together. But of course here we didn't really do anything other than check that this was the correct factorization. Okay, so what we're going to talk about next is how to actually find these linear factors for ourselves. So I wanted to give you a roadmap of sorts of how to strategize and go about factoring a quadratic that you might be working with. So first things first, a question you should always ask is there no constant term? Because in that case, it's actually a pretty short, simple story. So for example, let's say our quadratic is x squared minus 5x, and indeed there is no constant term. So all we're going to do here is factor out a common factor. So because there's no constant term, both terms that are there have a common factor of x. So I can pull that out the front and write this as x times x minus 5. Okay. Well, that's quite a special situation. We won't always be in that situation, unfortunately. So the next special situation to consider is your quadratic a difference of two squares? Okay, so in that case, we can apply a formula, which is really nice. Okay. So let's say that we're looking at x squared minus 9. Indeed, this is a difference of two squares because we have x squared and 9 is 3 squared. So in this case, we can just use the formula x squared minus a squared is x plus a times x minus a. So for this example, I can write x squared minus 9 as x plus 3 times x minus 3 with very little thought involved. Okay, what if we're not in either of those two special cases? Well, we're going to do what we call splitting the middle. So otherwise, we're going to try splitting the middle term. And as is often the case, the best way to see this is with an example. And indeed, we're going to redo our first example and try to reverse engineer what went on there. So here is that first example again. And I want to try and justify for you where that plus 3 and that plus 4 came from by looking at how they take part in the expression once we've FOILed out the brackets. Okay, so we have this plus 3, and that certainly contributed that plus 3x. And I have this plus 4, and that contributed this plus 4x also. But there's also a sneaky contribution from the 3 and the 4, because 12 is, of course, 3 times 4. So looking at this, we can figure out a goal when we're trying to factor a quadratic. We want to find two factors, so a factor pair of the constant, which in this example was 12, And we want those factors to sum to the x coefficient, which in this example was 7. And so this is why the technique is called splitting the middle, because we have this middle term, 7x, and we're splitting it up in a clever way that lets us factor. We're splitting the 7x up into 4x plus 3x. Let's see if we can use this observation to actually carry out a factorization all on our very own. Okay. So in this example, let's try to factor the quadratic x squared plus 6x minus 16. Okay. So I want to try and write this as a product of two linear polynomials that looks like this. So x plus a constant that I haven't worked out yet times x plus another constant that I haven't worked out yet. Well, let's extract the relevant information from our quadratic expression. So I have this negative 16, that is my constant term, right? So that's an important player for us in this method. And I'm also looking at that middle term, that 6x. Okay. So if we remind ourselves, what was our goal? What was our method? Well, I want to look at factor pairs of that constant term. So in this case, it's negative 16. And I want to find two such factors of negative 16 that sum to the correct coefficient. So in this case, my goal is that coefficient of x, 6. And now all we have to do is be methodical and check all the factor pairs of negative 16 and hope that we find a pair that sum to, in this case, 6. So let's check. Well, there are some easy ones that we can check. Certainly 1 and negative 16 multiply to give me negative 16. But when I add them, I get negative 15. That's not so great. Okay, that's not what I'm looking for. But let's not give up, let's keep looking. Well, okay, the other easy factor I could check would be, factor pair I could check would be negative 1 and 16. Those certainly multiply to negative 16, but when I add them, I get positive 15 this time. Again, not what I'm looking for. I want the sum to be 6. Now, if I'm methodical and check all my factor pairs, okay, so I could check 4 and negative 4, those sum to 0. That's not right. If I'm methodical, hopefully I will eventually find a sum of 6. Starting to run out of ideas, but I know that 2 and negative 8 multiply to negative 16, but they sum to negative 6, very close, not quite right. And of course I've set it up so the last pair that we check is going to be what we're looking for. That won't always happen. Sometimes you'll get luckier, but negative 2 and 8 multiply to negative 16, and when I add them, I do indeed get 6, which is what I wanted. Okay. So that negative 2 and positive 8, those are the numbers that I'm going to insert into my factorization. Okay. So my thought is the factored form of x squared plus 6x minus 16 is x minus 2 times x minus 8. The good news is I can always check, pretty quickly in fact, just by foiling. So let's check what happens when I do x minus 2 times x plus 8. If I do my pairings, I'll get x squared plus 8x minus 2x minus 16, which is indeed what I wanted. X squared plus 6x minus 16. Now, it really is that simple, except for when it's not. Okay, so I do want to give you a warning, which is that not every quadratic factors nicely. Okay, and by nicely, I just mean using integers. Okay. Nice whole numbers being added and subtracted. Okay, so let's see an example where this kind of goes wrong, unfortunately. Okay. So let's look at x squared plus 9x plus 6, and we're going to try to factor it as a product of linear factors. Well, okay, what do we do? Well, I look at my constant term, which in this case is plus 6. I look at my coefficient of x, which is 9. So in this case, I'm looking for factor pairs of that constant, which is 6. And I want them to sum to, in this case, my goal is that coefficient of x, 9. Well, let's go hunting for factor pairs. Well, we can get the easy ones out of the way first. 1 and 6 multiply to give me 6, but they sum to 7. -1 and -6 multiply to 6, but they sum to -7. 2 and 3 are a factor pair of 6, but they sum to 5. And -2 and -3 are also a factor pair, and they sum to -5. So none of these sums worked out to 9, which is what I was looking for. And if we sit down and think, have we been methodical? Well, yes, we have found every possible factor pair for that constant 6, and none of them worked. So splitting the middle didn't work in this case to factor our quadratic. But there is a silver lining. Because remember, I told you not every quadratic factors nicely. So if a quadratic can factor nicely, then it will factor nicely. Using the splitting the middle method. Do you want one more minute of math? Well, then I would encourage you to try factoring the quadratic expression x squared minus 23x plus 120. There are quite a few factor pairs to check, but I'll tell you right now, one of them will work. You will be able to factor this. And if you'd like to do X minutes of math, Y more times, don't forget to subscribe to this channel.